So it depends on what. So so it depends on what. If it's on a Friday, then you read the results first.
No, it depends. There are times I'm looking out to maybe optimize some protocols. So I will go straight to maybe the next one.
And then other times, yeah. So I'm very often I'm reading papers for the methods. So I will go straight to the methods, and then Tracy and I were discussing this thing. After your methods, maybe the methods, maybe the then maybe you're interested in like the outcome, something like somebody's trying to characterize something in the paper. So like they're trying to say, this gene is associated with increased virulence or whatever it is. Then if it's a paper like that, then you might read what? Results or discussion. Normally discussion. Results is like raw.
Who reads the introduction last?
Who reads the introduction? Who reads the paper top to bottom? Introduction, blah 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 blah. Okay. There's a top to bottom reading here.
I can go back and read top to bottom after I have first seen, then I find it interesting, then I sit down.
So, but most of us do a bit of a jump. Abstract, jump to the meaty stuff. Because the introduction is normally background. Okay, so it's like la 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 la. This is why people are getting like they're copying introductions from other places these days sometimes. But then the meat and the conclusion is a wrap up. Often I'm like, the conclusion is a wrap up, but I really want a discussion about the conclusion to see, because the conclusion they're like, normally it's like more research needed, and those kind of things. Okay. Then the next thing is, if you're reading a paper, now I've just given you, these are blog posts and a preprint, but when you're finding a paper, be as honest as you can be. How do you judge whether you think this paper is right?
I would look at, definitely the objective first. Compare the objectives with the title, because many times the title would mislead. And okay, when I see the title, okay, I already have something I'm looking for, and then I go to the objectives and I'm like, they don't.
You're overselling.
Yeah, exactly.
So that's the interesting one. That's like said. Look to see, does the paper actually deliver on its promise? Okay. Do you look at like which journal it's in? Tracy was asking me, do you look at the impact factor of the journal? I must say I never look at impact factor. But I do look, do I know this publisher? Because then if it's from a journal called Bioinformatics, but it's by the great scientific publishing group that I've never heard of, then I might Google to see who are this publisher, are they really credible? Because there's a lot of like fake, well not fake, but like poor quality papers in the world these days. I'm not saying that like if it's in Nature, it's like a great paper, because there are some rubbish papers in Nature, as well. But like I do look to see, do I know this publisher, and I mean, not every paper can be like a top paper, because like it might be something about like, it's difficult to get a paper about like, the foodborne outbreaks in Togo, into a top journal. They're going to basically say, this is like a regional study or something like that, So I do take that into consideration, but I do look at like, and then of course, but the other thing for quality, and Tracy was noting this to me when we discussed something just now, is, look, obviously when you're new, it's difficult to judge, but I normally look, this approach, is it kind of similar to something, or this thing, is it a little bit similar to what I've heard before, Because sometimes, like, there'll be something totally new, but I find science moves forward in little steps. So try and map what you're seeing to like what you already understand, You know. Okay. So what key messages did you get from these two blog posts and one preprint?
Everybody makes mistakes and everything makes mistakes.
And I must admit, I was quite amazed by some of the results when I read them. Okay, but other people, when you read these blog posts about nanopore sequence assembly, so Ryan Wick has been working on this problem of sequence assembly for a long time. Okay, but what were some of your key take homes that you found from this?
Okay?
Yeah. So,
You cannot trust one tool,
Mhm.
but you should always compare your analysis using different tools to see if you kind of
get the same results. One thing I'm taking home from this stuff is, if you can avoid it, never use fast mode in nanopore, okay? Which is a problem with the Mark 1C because that thing is very slow. So if you don't want to, so with the Mark 1C, you're kind of stuck because you to use super accuracy mode or high accuracy, it takes much longer, okay? What? Yeah, on the Mark 1C, because internally the Mark 1C has about 600 CUDA cores. That's the compute elements that these accelerators are measured in. But if you look at RTX 3080, it's a few thousand CUDA cores, right? If you're using a V100, that's what's in the Gridiron, then I think it's also a few thousand CUDA cores. I can't remember exactly. Who's got a Gridiron? Noguchi has a Gridiron. Okay, so you got the V100. Okay, and who is using an external computer to do their base calling? Yeah, and do you know which GPU you've got in there?
So the old laptop is kind of bad now. So what I do is I copy and
Okay,
I copy from my personal.
and that's got a better GPU than the old laptop. The old one is the one that America was working with back in 2020.
Yeah,
Because my colleagues downstairs, I think they've still got a 2080 or something like that. These things upgrade all the time. So now apparently we're on 4080s already. I saw somebody say, hey, you too can do machine learning model training at home. All you need is a PC with two 4080 GPUs. I was like, all you need is like, like, $4,000 worth of computer, US dollars, not Namibian dollars. But yeah. So, but besides the other thing, so about the models, right? The other thing that I noticed in this paper, okay.
Is not discontinued.
Is it officially? But there is not yet. Is the Mark 1V out there?
Yes, I think it's on trial experiment. I think it might actually be.
Has anybody here actually had a Mark 1D in their hands? The Mark 1D, I've seen pictures on the website and they say it's early release. But I think that what they're doing with the Mark 1D, if I get correctly what they're doing, just close my WhatsApp, it's being chatty. I think the Mark 1D, they are using an M1 chip, like in the latest Macs, for doing their base calling. Okay? Because the version that I saw was basically using a, what's the thing called? An iPad, which is the latest iPad with a Mark 1D chip to do the base calling. But that's about all I know. And the thing is, I don't know how to compare that against like the other approaches we've got. But anyway, yeah. So there's I still think that sticking to a laptop with Mark 1B makes more sense than these other ones that you can't upgrade. But if somebody wants to give me a Mark 1 If somebody wants to give me a Mark 1D for free, I'm not going to complain.
Good.
So when are the ones that Mark 1D to Peter?
What?
Mark 1D.
Yeah? What about Mark 1D?
Judge can donate.
You can donate to poor, starving, Mark 1D-less people. Okay.
Peter,
Yes.
one, the third issue.
The third
key,
issue.
Key message from. So personally, I think the message I took from at least two of the blog posts was that it's not just enough to say you're using a tool on maybe certain parameters, say default parameters. So I'm using fly for maybe assembly. So I get it. Just put it in because I think one of them gave results of different modes of the various, I think, a particular place called line. So algorithm. Yeah. So it's like it's not just enough to say you're also using multiple tools. Even within one tool, you could get different outcomes depending on how you treat the parameters and so on. So I think that's also a key give
There was a key message. Another thing that I took from this thing is that my learning is never done. Because I never heard of this other res bacteria tuned base caller before I read this blog post. I never knew that you could get custom base calling models for Oxford Nanopore for Dorado, okay? Which, like, I was just using it out of the box with what they've done themselves. But yet, if you look at the results, they did get better results with this customized. If we look here with our Vibrio cholerae, then with the super accuracy, they got 22 errors in the genome, okay? But with the res, they got 0. And that's only using nanopore reads, okay? So I'm quite impressed by this thing. The other thing that I took home from this one, the thing that frustrates me is that they always talk about the accuracy. And yes, the accuracy is getting better and better and better and better, okay? But, where did they say? This sentence, there are still some E. coli errors in this methylation motif and CAMP errors in this methylation motif. So in other words, methylated DNA is still causing problems for the base callers, okay? But long polymers, homopolymers sometimes have indel errors. So we still have, and I mean, 10 base pair homopolymer is long, okay? But indel's problem has not been totally solved yet, okay? And then the last thing that then just going to the next blog post, I just found this one was interesting. I mean, this was just a short blog post, but I found this misassembly was interesting. That you've got this situation with these very long repeats, and the sample had reads from both ways round. So maybe within the sample, there's actually a diversity, even on that small level of the organism. And then, of course, the assembler can't resolve that, okay, automatically. But it was just an interesting thing. And by the way, the sample that they're looking at there, the ATCC 14035, I'm almost certain that that is the N1691, forget the number, but you know the Bangladesh 1975 cholera sample. Because if you go read in the literature, you'll find that the original 2000 genome had a misassembly. And the misassembly was like this kind of inversion. So I think that it is the same sample they're talking about. And then on the last one, really what struck me on this preprint, I read through all of the thing, and sometimes it's also a way that I read sometimes. What absolutely struck me was this picture. Okay? And this is where they get their take-home message from. That as your Illumina depth increases with the polypolka, which they said is the best, okay, with the careful mode, as your depth increases, the error rate dropped to like 0 in this one. It worked really well. But over there, at the start, as they say, it introduces more errors. But this to me was an example of a picture that says 1,000 words, because just looking at, having read the background, where they're having lots of words and discussion, but then looking at this picture, you just see, boom, the errors just go down to nothing there at around 20, 25. But that does mean to me that before, if we're going to do nanopore and Illumina sequencing, before we use the Illumina mapped reads for polishing, we must filter by depth and remove any regions with lower than 25 mapped reads. We must eliminate those, because else we're going to actually start introducing errors there. And then, yeah, but if you can do this, it was quite impressive. Okay, just, I don't really have anything planned after lunch, but I would like to do one more paper, okay? So the last paper is the one that we did, the one on read mapping. Maybe because of time, we must look at this one together, okay? And this one is a good example for me, just zooming in to the methods. And like, and not even all of the methods. I just was like, which of the methods was I zooming in on? So this, I don't know who had a chance last night or this morning to read this paper, okay? But I felt like the two papers that I put together for nanopore were relating to the two different methods for investigating bacterial genomes. The assembly, de novo assembly-based method, which you use together with MLST or CG-MLST for looking at clusters of similar alleles, okay? And then the SNP-based method, okay? With Bogarts and all of these other people, okay? And anyway, blah, 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 lots of background, skip over the introduction, yes, it's getting better, we like nanopore, etc. Okay? Then we collect some isolates, yes, we collect some isolates, people get listeriosis, we collect their poop, all of these things, and E. coli, and then we extract some DNA. All of this to me is just magic, like they do some stuff. I don't know, you guys might know what that means, of just like they do some stuff. Then they sequence it, okay? And they sequence Illumina, and they sequence long read, okay? And again, I then like zoomed in on, I normally want to see either the code or this, okay? So then I wanted to see the picture of the workflow. Having seen the picture of the workflow, let me read the text much easier, because now I know what I'm looking for, okay? So what they do, they use scKit. So if you go read in the methods, just leaving aside all of the stuff of Illumina, I'm not paying attention to that. They use scKit and they filter by average quality and by length, okay? Which is the same thing that you do with Filtlong, it's the same thing that you do with NanoCube, okay? So everybody seems to be using the same approach to doing quality filtering of nanopore data. Throw away your short reads, throw away your low quality segments, okay? Not counting about Amplicon, that's different. Then they map, Minimap 2. There's lots of mappers in the world of short reads. There's Bowtie, there's BWA, there's other things. I've never seen anybody use anything besides Minimap 2 for mapping ONT reads, okay? And by the way, Heng Li, who the author of Minimap 2, just released a new version of Minimap 2 this week, where they, because there's a preset setting for nanopore, and he's now come out, based on experiments from the Nanopore company, they've come out with a new preset called ONT HQ, high quality, for the new R10 reads. It's got just tweak some of the parameters a little bit. Then the next thing they do is snip calling, and I was quite interested here. So I'm going to go back into the text. So they did snip calling using BCF tools.
Peter, before you proceed,
Yeah.
just keen to know how do they combine the mark reads from the two?
No, those are not being combined.
Okay.
That's
Those
good,
they
good
do
question.
separate.
These are two separate projects. So that's the incorrect arrow there. Okay? It makes it look like they're combining. But what they're doing is they're doing a comparison. Do we see the same snips with Illumina as we see with ONT? Yeah, it's pointing to the step, but it's not a good picture to me. Okay? So then we go read. So on they have a Galaxy server, which is for you have to register to use it. It's a bit kind of closed, but so it starts off by looking at the input BAM files. So then it looks to check that the coverage is at least 95% of the genome, and that the depth must be at least 20 times across the whole genome. Okay. Then they do a two-step. Okay, they do an MPileUp followed by call BCF tools. So BCF tools MPileUp is just basically taking your BAM and computing a structure showing where all the overlapping reads are. Okay, it's a necessary step before you call BCF tools call, which does the variant calling. Okay, and this is where things got interesting to me. The skip variance option was set to indels. So what do we see here? Because I'm always interested in like the indel problem in Nanopore. And so they decide that they're only going to call single nucleotide variants. Okay? And the ploidy, it's haploid, so the ploidy is set to 1, and then the consensus caller option is enabled. Okay? Then the prior option is set to these values for Illumina and ONT. Okay, so this is basically about the expectation of errors. I have to read the man page for BCF tools call to understand exactly what prior means, but it's basically some kind of Bayesian prior related to your expectation of errors. Okay. Higher values of this option increase the sensitivity of snip calling, and tool recommends using this. Okay, and then they did some filtering. And how they filtered what they call soft filtering. So in other words, they didn't delete the entries from the VCF, but they just kept the entries, but they put a filter message in the filter column. Okay, so they recommend you to not use those, and that was based on the allele frequency, depth below 5, or SNP quality between 50. Now I'm a bit confused by this because I thought that they'd eliminated everything with less than 20 times coverage, but maybe they were earlier on. They were eliminating with less than 20 times average coverage. But then, anyway, so they're not calling variance at anything less than 5 reads supporting that. I must admit, 5 is low. When people use, I guess things are changing with Nanopore. In the past, we used to say 20 reads of Nanopore, but now maybe with the new higher quality 5 reads, they're saying it worked for them. And SNP quality below 50, the SNP quality is computed, if I understand it correctly, and correct me if I'm wrong, anybody who knows this, by adding together the quality. So the SNP quality is computed by the caller, but a lot of it has got to do with adding together the quality of the incoming reads. So do you have high enough, but I'm not sure. It's but anyway, that maybe more research is needed. George, do you know SNP quality? Is it how is that the calculation of a SNP quality in a VCF? That is also caller dependent, right?
Yes.
But in general, I've seen it be like a combination of the quality of the incoming bases. So you add together the
Yeah,
incoming,
base sort of.
base qualities. An in-house script was used to soft filter SNPs that are located within 10 bases of another SNP. Now this is interesting, okay?
How do they pass an editor? An in-house script. Without providing DOI or
But always in-house scripts. I'm finding it all the time. But the reason for this is interesting because if we go back to the top, okay, this comes back to my experience with Medaka, where Medaka with Oxford Nanopore was putting in incorrect indels, okay, and then I couldn't understand how the MinION pipeline was not having incorrect indels, and I realized that they were just discarding all frame shifts. Okay, so this is just how do you deal with the problem? Well, you just throw it away. That's basically what they did. So if you've got a difficult, but that's fine because remember when we are doing SNP-based phylogenies, we're not using indels anyway. So this is a fine approach for this. But the other thing about this rule, okay, yes, this sometimes is related to, you get these clusters of SNPs because of recombination, so that is valid. But I'm also reading that and I'm thinking that one of the weaknesses of BCF tools, MPILAP approach, is that when there is an indel, callers like FreeBayes do what's called local realignment. They'll realign the reads around the indel, and that increases the accuracy. GATK, the late, will also do that. That increases the accuracy of calling variants close to other variants. Okay, but this is fine. They must have had a reason for this, but it's just interesting that they're not that they've got that filter. And then once they do that, then they take the SNPs. They make a consensus genome using BCF tools consensus, and then they merge the resulting sequences into a single phosphate file, and then they put it as input to governance. At this point, we basically are doing the same thing that we've been doing in our SNP pipeline. Okay, and governs to detect recombination. Then they basically masked out low depth regions. And now they're going to actually using the genome for analysis. They're going to run faster to identify prophages.
Is that also tunable or low depth region?
Low depth regions, they. Okay, so here we get to the mapping quality thing here. So let's have a look a little bit closer. Low depth regions were identified using the depth functional sample with a minimum mapping quality set to 5 to exclude secondary alignments. Okay, this comes to exactly what we were discussing with George earlier, that the low numbers in the mapping quality, so 1, 2, 3, 4, 5, normally mean multi-mapped reads. So they're excluding any multi-mapped reads, and they want at least 5 depth of reads that are individually mapped, not mapped to multiple positions in the genome. Is that tunable? I'll have to look. The code is online. It's all in Python. It probably is a parameter somewhere.
So are you sure whether this is only for Illumina or ONT?
No, they're doing this for everything. At this point, they mention when they do things differently for ONT. At this point, if you look at the pipeline, this is taking the BAM files. So at this point we're in this part of the pipeline. This part of the pipeline, low depth regions, governs, all of that kind of stuff. So we're taking these these are not merged. We are taking BAM files here, whether they're called from Illumina or whether they're BAM from Illumina or BAM from ONT, and the rest is starting to be the same, just with some tweaks to parameters here. BCF tools called. Okay, And then they do some other stuff there, governs the low depth regions. And now we're going to do tree construction using Mega, whatever you could do it with IQ tree, same diffs. Okay? Really is not important what they're doing. And then they get a distance matrix, a snip distance matrix, they get a phylogeny, and now they probably go and make some picture with it using some of other visualization software. I didn't go into that, okay? But what I found interesting about this thing is that then the results are that they are able to, so the running times and performance and all of those kind of things required sequencing time, because obviously this, how long must you sequence in order to get enough reads? And the read mapping, they give lots of statistics. I'm trying to get to the results now. Okay. Okay, so not that surprising. When they were comparing the SNPs that were called, the largest number of unique variants were always exhibited by R9 nanopore, the lower quality nanopore, whereas the number of SNPs uniquely detected in either R10 or Illumina was much lower. Okay, after filtering, the vast majority of SNPs were still shared. And the number of SNPs in E. coli detected by R10 and R9, the nanopore, was higher than those detected by R10 and Illumina, okay? By both. So in other words, there was more commonality. There still is more commonality between the two different generations of nanopore than there is between nanopore and Illumina, okay? And similarly for Listeria, and there's nothing shared by Illumina and R9 that's also seen in R10. Okay, so and so then they use what's called a upset chart to show that, like, overall, what we get is, now they haven't labeled this, that's easy for me to read, but basically that the intersection vastly, they've labeled it, the intersection that we're seeing the same SNPs vastly outnumbers the differences, okay? And between R10 and Illumina, then there's these together, but this is what they're showing about the commonality between the R9 and the R10, okay? Moving down to the, and what we see here, this on the left-hand bar, the 28 at the top and the 145 in the bottom, and this is before filtering, right? Is that the unique SNPs are isolated here in the R9, the lower quality. But after filtering, those also go away, and we have this huge amount of similarity between the different technologies. And lots of analysis of the phylogeny, but we see that basically in their phylogenies, and they give the pairwise SNP distances, and we just see so much correspondence. Bottom line from all of this thing, my conclusion is that there are still some differences between high quality nanopore and reference-based mapping with high quality nanopore and Illumina, but on a single nucleotide variant level, because remember they excluded the indels. Then if you want to do SNP-based outbreak investigation, the numbers are very, very close together, okay? That said, if we compare if we put our SNP distance threshold, if we have very closely related samples in an outbreak, we still are going to have a challenge. Because sometimes, if you really are trying to puzzle apart an outbreak, you're going to have a SNP distance threshold of 10, below the, like in, or something like that, to consider them like kind of related samples. It depends on where you set the threshold, okay? The number of differences was still big enough in that it could, if you make it difficult to distinguish like really closely related samples. But in terms of the general picture, no, this is, we can now, so the only thing for me is that we can use the nanopore technology. To some extent, we can even use the R9 technology for SNPs, because after filtering, the number of SNP differences was very low. But we need the tools and pipelines and things for that. And they've offered one kind of tool. You can use their pipeline, But anyway, anybody got any other comments on this paper? But this was my take home from this paper. Well, it's getting hot and everybody's getting tired. I think they want to have lunch. But I mean, I feel like there's more tooling that needs to be worked on nanopore, but the results are very it's for SNP-based work. You might be able to use the same thing, the two different technologies.
Edith, before you switch